Dear students, let us discuss next topic in this chapter, uh, which is Lami's theorem, which is again a very important topic. This theorem states that if three coplanar forces acting on a point in a body keep it in equilibrium, then each force is proportional to the sine of the angle between the other two forces. The example is given here. These three forces P, Q, and R, they are coplanar and uh, collinear, and the angle there, the direction of each is outwards from the point O, and this theorem says that P divided by sine of alpha, which is the angle, alpha is the angle between the other two forces other than P. Okay, so P divided by sine alpha, Q divided by is equal to Q divided by sine beta, and R divided by sine gamma. So this is the theorem which will be applying to solve a few problems. So let's discuss problem number 2.14. So in this problem statement, three forces keep a particle in equilibrium. One acts towards east, which is shown over here with 5 Newton force, another towards northwest, which is shown with the symbol P, and the third towards south, which is shown with the symbol Q in this figure 2.31. If the first be 5 Newton, which is already shown in the figure, find the other two. So in this, the solution is simple. We will apply the Lami's theorem. So P divided by the sine of angle between the other two, which is 90 degree in this case, you can see between this 5 Newton force and Q is 90 degree, is equal to Q divided by sine of 135. So Q divided by the angle between this 5 Newton force and P is 135 degree, is equal to 5 divided by sine 135. So this is the third given force 5 Newton, and the angle between the other two is again 135. So in this way we can find out the value of P as well as Q with this given equation. Now let us discuss the next example, which is 2.15, which is shown with the help of this figure 2.32. A machine weighing 1500 Newton is supported by two chains attached to some point on the machine. One of these ropes goes to the eye bolts in the wall and is inclined at 30 degree to the horizontal, and the other goes to the hook in ceiling, and which is this one, point B, and is inclined at 45 degree to the horizontal. Find the tension in the two chains. Again, you see here we again can very easily apply the Lami's theorem, and suppose T1 is the tension in the first this chain or string, whatever, and T2 is this tension in this chain, and the weight is given here 1500 Newton. So simply we'll find out the angle between all these the chains as well as the string where you have this 1500 Newton force. Okay, so T1 divided by the angle between the other two is 90 plus 45, which is 135, is equal to T2 divided by the angle between the other two, which is 90 plus 30, which is 120, and 1500 divided by sine of the remaining angle here, because this is 180, 30, and 45. If you reduce these, it becomes 105 over here. Okay, so this is the equation, and we can easily find out the result of T1 and T2. Next example, we will straightway go to the 2.27 that I have noticed. Okay. Yeah. The cylinders shown in the figure 2.44 have the same diameter, but the cylinder 1 weighs 200 Newton and the cylinder 2 weighs 150 Newton. Find the reaction at the support. So the arrangement is shown like this over here. This is an inclined plane at an angle of 15 degree with the horizontal. So this is the first uh, cylinder, and this is the second cylinder. Then they are touching each other, as well as this one, the cylinder 1 is touching the wall as well as the ground. Cylinder 2 is touching the first cylinder as well as the ground, which is an inclined plane. Okay, so the following forces keep the cylinder 2 in position. Weight of the cylinder, and which is W2, 150 Newton, which is acting vertically downwards. Reaction RS, which is reaction of the cylinder with the inclined plane, and reaction of cylinder 1, Rn, in the direction O1, O2. O1, O2 is the line which is joining these 2 points. Action and reaction are equal and opposite, so we'll apply this to cylinder 1 as well as cylinder 2, the same thing. So again, we will have to find out the angle and we'll apply the Lami's theorem in this. Okay, and let us see, Rn divided by, this is Rn divided by the angle between the two, which is the angle, because see this the reaction at point S is coming here, but we will take it here at the center point, moving in the upward vertical perpendicular to this plane, which is shown with the help of R. Okay, so this is 1, and this is W is again outwards, and this is again outwards. So okay, yeah, so we'll take this reaction to be pointing towards this direction. Okay, because this cylinder is being applied with the force which is towards this center O2. So we'll point it from O2 towards the right. Okay, although in the figure it is showing in the, this arrow is showing on over here. So accordingly we will find out the angles. So for this force R, so we'll take the angle to be for this R, we will take the angle to be this one, which is 180 minus 15, and then for this we can take the angle to be this one, which is 90 plus 15, and then last one is W2 divided by sine 90, because the angle between this and this will be 90 degrees. So this is all. So after we find this, okay, so we can find out the value of Rn and Rs both. Okay, and similarly the next thing we can do is we can apply on this cylinder. Okay, so there is one force which is RL, the reaction at L, which is horizontal along this direction. So Rn will be in this direction, leftwards. Okay, and Rm will be upwards, and there will be W force. Okay, so this way you can there are 4 forces, so here we cannot apply the Lami's theorem, so we will have to resolve the forces along the horizontal direction and resolve the forces in the vertical direction, and because the system is in equilibrium, we can equate these components to be 0 and find out the value of the forces, that means RL and RM, which is given over here. So this is all about this problem. Okay, thank you.